So yes, we now know what data is. We now know the different types of data. We also know the different measurement scales. Now, can we look at a little bit of some basic tools that at least we should know from the start about handling data and its simple manipulation of this data. So we are going to look at tools basic tools, fundamental tools. They basically give you the right foundation to do everything you want in statistics. And these are three things: rate, ratio, proportions. So we want to know what each of these actually means and uh, the different examples that we can give under this. So ratio. A ratio is when you have a given quantity divided by another quantity. As simple as that. So if you have in a shop, how many shop attendants do you have? Okay. If you have, let us say, 8 attendants, and then out of those 8 attendants, you have um, the sections where people are paying money. So out of those 8, you have four stations for where people come in. They enter the shop, pick what they want. Let us say if it is a supermarket, and then they come and make payment, and then they exit. So if you have a big supermarket with 8 attendants, and then out of the 8 attendants, you have four sections where people come and make those payments. So what you basically have is that you have eight eight staff divided by the four stations. So the ratio is 8 to 4. That's what that means. It doesn't mean that the quantity that you're dividing has to be the same, but sometimes it can be the same quantity. If we are talking about a hospital, what is the ratio of doctors to the patients that we have? Or what is the ratio of nurses to doctors? What's the ratio of nurses to midwives? All the ratio is dividing any quantity with another. That's what we call a ratio. Now, a proportion is that uh, you have the numerator being part of the denominator. Now, if you have, let's use this. If in a class of 12 students, 8 of them are boys, what is the proportion of girls? It will be, the girls in this class are actually 4. There are 4 girls out of 12. Now this here, 4 out of 12 is a proportion because the 4 is a numerator, the 12 is a denominator. The 4 is part of the 12. So that's why we're saying the numerator is part of the denominator. So we can convert this into a percentage and we can determine the percentage composition of the class in terms of gender, and we can be able to have that percentage. So that means that a percentage is actually a proportion because the numerator is part of the denominator. And then we have a ratio, a rate. A rate is a ratio that has time to it. Okay? If you hear anything about rate, there's usually time dimension with that, and we shall see that shortly. So the interrelation, okay, and how is a proportion related to a ratio and how is a ratio related to a rate? Okay, so a rate is a ratio because you're dividing, okay, but there is time to it. So a rate is a ratio. That should be very simple to understand, right? Okay, if we say that let's just come back here in terms of the rate. The example that we can give here is that every year, 12 girls die due to early pregnancy. Okay, complications, early pregnancy complications. every year you have girls that are dying. Okay, so for us to have it as a rate, if you are saying 12 out of 1,000 girls that in a particular community are dying every year, that is a rate. So we are coming here and saying that the rate is a ratio because of the fact that there is this what division that we are having there. So a proportion is a ratio, okay, because we are dividing, and what we are dividing is that the one above is part of even what is down. So proportion is a ratio, but not all ratios are proportions or rate. Okay, that's also very vital there. So that means that if you have a ratio, you just need to know whether it is a rate. If it is a rate, if there is time dimension to it. If the numerator is part of the denominator, then that ratio is actually a proportion. So those are things that you know. So further application of this simple basic measurements tool, we have when we are looking at the rate at which a particular event is happening. Okay, so each year how many people are dying because of accidents, and then you can give that number. So that number can look at either, if you're looking at of those who have had accidents, how many are dying in a year, or you can say out of the total population of a particular community, we have this number of people are dying because of road traffic accidents. That's basically what we are talking about here. Properties of rates. Time is always there. If you look at any number and there is always a time dimension to that number, think about a rate. So rate, this time can be in different units, seconds, hours, days, years, and things like that. Okay, so that is what you can talk about there. In health, you can look at cases that we have per 1,000 person years. This is a concept that you learn in the other modules like epidemiology. Okay, so it's the same thing that we have in here. How many people are getting a particular condition per the population that we are having? Those are usually rates. And then ratios, one number divided by another, or it's about one quantity divided by the other, or it is one value divided by the other. Okay, they can be related or not related. So ratio is the A over B. It doesn't matter. You can actually have B over A. It doesn't matter as long as you're dividing something. Okay, and then if you're talking about large quantities, usually you can have you can multiply the ratio in tens, in thousands, in 100,000, and things like that. It may or may not have units. It's very vital depending on what you have divided. Proportion, a percentage is actually a proportion. For example, you can say the total number of fatal death that happen per total life births. That's a proportion. Okay. Or for example, if you are looking at of all people who come to the clinic, how many of those are seeking for family planning services? That's a proportion. Or of all people that visit a particular shop, how many of those are female? That's a proportion. So things like that, and it can range from 0% to 100%, or 1, or from 0 to 1. Okay, they have no units, right?